More than 5.5 million people in the U.S. suffer from fecal incontinence, most commonly those over the age of 65 and women. 6.1% of those over 65 that suffer from fecal incontinence have liquid or watery stool, and this number may be higher in an ICU where a high percentage of patients are sedated or ventilated. Our market is at least 335,000 people, with DigniShield's average selling price being $110, bringing our service attainable market to $36.9 million.
Current external solutions prolong skin exposure to fecal matter, causing increased risk of skin breakdown and dermatitis, leading to pressure ulcers. Internal fecal management systems commonly include an expandable cup that is inserted into the anus. The cup collects the stool into a tube, which diverts it into a collection bag. However, these internal systems are not without deficiencies, as they can only handle fully liquid stool.
An internal management system that can accommodate a wider range of stool consistencies would reduce the rate of incontinence-associated dermatitis and pressure ulcers in non-ambulatory patients, and reduce costs associated with pressure ulcers that typically fall in hospitals. Our team is Peachy Clean, and our solution, sponsored by BD and their current internal fecal management system, DigniShield, draws inspiration from the biological peristalsis of the colon. In our proposed design, the tube would contract repeatedly in a way that mimics the mechanism of food breakdown in the GI tract to further break down stool and allow for the use of DigniShield to accommodate a wider range of stool types. To mimic peristalsis, we plan to use a memory-shaped alloy wire or polymer embedded in the tube that would contract and expand the tube when a current is applied.
We tested our device for efficiency based on two design inputs. In order for the tube to be able to perform peristalsis, the tube needs to withstand contracting to at least 50% of the tube's original diameter. Using a von Mises stress test, we found that 25 newtons of force are needed to displace the diameter of the tube by at least 60%.
In addition, verification of the velocity profile of a semi-liquid stool replica through the tube was needed. Semi-liquid stool was simulated using a maximum dynamic viscosity of 2.92 pascalseconds. Without peristalsis, the fraction of flow reaching the end of the tube is 35%. However, when the force is applied, 100% of the flow diverges to the end.
The novelty of our solution is that it would be able to accommodate stool types with a viscosity ranging from liquid to semi-solid. This would allow more patients suffering from fecal incontinence to use an internal fecal management system, reducing the need for external management devices.
A study found the cost of only incontinence treatments for each institutionalized patient to be just under $10,000 per patient, and pressure ulcer wound treatment costs hospitals between $8 and $11 billion per year. As more patients are able to use an internal fecal management system, there would be a reduction in the cost and manpower necessitated by the treatment of dermatitis and pressure ulcers.
Our next step would be to create a physical prototype with the memory-shaped alloy wire. We would conduct physical stress and voltage tests to determine the exact specifications. We will also need to conduct mock stool tests to determine the necessary contraction speeds and frequency.
Although the current DigniShield is classified as a Class 2 medical device, the addition of a power component may affect our solution's potential Class 2 status and will likely necessitate performance testing before market approval.
We hope that our Peachy Clean solution may one day serve a wide range of patients suffering from fecal incontinence. Thank you for watching.